Hey everyone, and welcome to today's explainer on OCI logging analytics. Look, if you're a cloud architect, a DBA, or an IT operations pro, you already know that Oracle Cloud Infrastructure has a seriously phenomenal suite of tools for managing and analyzing logs. But as we all know, simply turning it on isn't always enough. So today, we're going to dive deep and master the art of optimizing your OCI log management. We're talking real-time analysis, massive cost reductions, and drastically faster troubleshooting. Take a second and think about your current infrastructure. Are your cloud resources pumping out so much log data that your dashboards are lagging? Or worse, are you noticing dropped logs when the network gets super congested? Because here's the reality. When you're dealing with massive scale, the default out-of-the-box settings often just won't cut it. Your logs are literally the lifeblood of your observability strategy. If that ingestion pipeline is choking, you are basically flying blind.
Okay, let's look at our roadmap for today. First, we'll cover the log ingestion challenge. Second, choosing the right agent. Third, management agent performance tuning. Fourth, optimizing volume and architecture. And finally, unlocking your log data.
All right, kicking things off with Section 1, the log ingestion challenge.
Before we jump in and start tuning any system, we've got to face the music about what we're actually up against here. In a modern cloud environment, resources are incredibly chatty. I mean, they generate such high-volume logs that they can easily blast right past the default ingestion thresholds of OCI. And when those defaults are exceeded, you're not just dealing with some minor annoying delay, you are actively threatening your ability to perform real-time analysis and threat detection. If a critical failure or a security breach happens, there's no way you can afford to sit around waiting for a backlog of logs to slowly trickle into your dashboard, right? Moving right along to Section 2, choosing the right agent. So in OCI, a really common strategy is to make your agent decision based on your destination service. Let's compare the two main contenders. On one side, you have the Unified Monitoring Agent, which is based on FluentD. Its destination is the OCI logging service. Now, this is great if you need to send data to external target systems, like a SIEM, but it does have a strictly limited list of parsers, things like JSON, CSV, syslog, and Apache, and you actually can't create custom parsers for it. It also caps your log retention. You're looking at 12 months for audit logs and just 6 months for service and custom logs. Then, on the flip side, we have the Management Agent, targeting OCI logging analytics. This thing is an absolute powerhouse for custom workflows. It supports custom parsers like regex, JSON, XML, delimited types, you name it. Plus, it supports a huge array of collection types, local files, syslog listeners, database SQL connections, REST API calls, even Windows event messages. And while it doesn't offer an export option for index data, its archive option is fully integrated right there in logging analytics. It's the whole package. Which brings us to the really fun stuff. Section 3, Management Agent Performance Tuning. So what's the big bottleneck? Well, it's 1.5 megabytes. That is the strict default upload limit per log bundle for the management agent. Literally, no matter how beefy your server is, if you're generating tens of megabytes of logs a second, they are getting chopped up and squeezed through this tiny 1.5 megabyte restriction. That creates a massive traffic jam, which means we absolutely have to do some specific performance tuning in the agent's configuration properties file. To bust that bottleneck wide open, we use the md.properties file. Think of your log data as heavy traffic on a highway. The _sender manager pool size parameter, which defaults to 3, dictates the number of parallel threads uploading those 1.5 megabyte bundles. It's exactly like the number of lanes on your highway. If you have 10 megabytes of log data, it splits into 7 bundles. With only 3 threads, it takes 3 full rounds of uploading to clear that traffic. But bump this parameter up to 7 or more, boom, all your bundles upload simultaneously. Next up is the _sender manager send timer frequency. It defaults to 30 seconds, basically acting like a traffic light that only lets cars through at set intervals. You can actually lower this all the way down to a minimum of just 1 second. And finally, for your absolutely most urgent data, we have _force send immediate. By default, this is set to false. Flip this to true, and the sender manager uploads files the exact second they're generated with absolutely zero delay. It's basically a VIP fastpass for your log data.
Now let's zoom out a bit for Section 4, optimizing volume and architecture.
Look, tuning is amazing, but to truly get the best ingestion performance from the OCI logging service and Service Connector Hub, you have to be ruthless about reducing your log volume right at the source. You've got to filter out the noise. Specifically, we're talking about removing those super verbose debug logs in the Service Connector Hub that don't add any real value to your analysis. Why does this matter? Because every single megabyte of useless data you ingest just inflates your OCI costs and junks up your workspace. By filtering early, you make sure your newly tuned management agent is only spending its high-speed parallel threads on data that actually matters to your ops team.
And this brilliantly illustrates another huge architectural theme here: centralizing your log collection. Instead of slapping an agent on every single individual node, check out this flow. Step 1, your network appliances or rsyslogd instances forward their logs. Step 2, all those logs funnel into a central syslog server. Step 3, we place one highly tuned management agent right on that central server, and we configure it to listen to the syslog port. Step 4, it efficiently batches and forwards all that consolidated data directly into OCI logging analytics. This setup is just elegant. It drastically reduces your agent management overhead, and it perfectly takes advantage of the high throughput tuning we just set up.
Finally, we arrive at Section 5, unlocking your log data.
The source material really hits the nail on the head here. It says, by adopting these best practices, you're not just adjusting a system, you're unlocking the full potential of your log data. We aren't just changing a 3 to a 7 in some random config file for the fun of it. We are guaranteeing timely log analysis and threat detection. We're empowering better decision-making, we're streamlining workflows, and we are massively boosting security. We are literally paving the way for operational superiority. So, I want to leave you with this final thought. Look at your own OCI setup today. Is your log data working for you, handing you instant, actionable, cost-effective insights? Or are you working for it, constantly fighting latency, bumping up against default limits, and digging through cluttered workspaces? Take these best practices, choose the right agent, tune those parallel threads, filter out the noise, and centralize your architecture. Apply them and watch your logging transform from a frustrating bottleneck into your most powerful operational asset. Thanks so much for joining me on this explainer, and happy tuning.